All right, in this next section, we're going to be talking about special right triangles. There's only two that you need to know. For this first one, it is something called the 45-45-90 right triangle. So what does it look like? If I were to draw a right triangle over here, and this is going to be our right angle, which is 90 degrees. Let's say, for example, this angle over here is 45 degrees, and this angle over here is also 45 degrees. This is a very special triangle, okay? It tells us a lot about the side lengths and also about the type of triangle we're working with. If you remember from like past lessons or like a past math class, whenever we have two angles that are the same, that means that the sides that are opposite from each other, so if this is 45, the side opposite, and then this one's 45, the side opposite, these are going to be the same length, okay? The same length. And what kind of triangle has two sides that are the same length? Isosceles. So whenever you have a 45, 45, 90, you have an isosceles triangle, which means that the sides that are opposite from the 45 degrees have the same length. So for example, x and x, that's the same. Or maybe even 3 and 3. Okay, so it's always going to be the same length over here. What does that tell us about our hypotenuse though? So in a 45, 45, 90, our hypotenuse is going to be the length of a side times root 2. So in this example, if the length of our side is 3, what is the length of our hypotenuse? It'll be 3 times root 2, or just 3 root 2. Okay, so let's go ahead and try out this example. So here it says, find the value of x. Write your answer in simplest form. Okay, so let's take a look at A. A here, we notice we have a right triangle. We notice that one of the interior angles is 45 degrees. If that's the case, then this angle over here is also 45 degrees. We have a 45, 45, 90, and that gives us a lot of information about our side lengths. Well, one of our side lengths is 8. Okay, so if one of our side lengths is 8, then that automatically tells us that the other leg is also going to be 8. So our hypotenuse of a 45, 45, 90, or our x value over here, is always the length of our leg times root 2. Okay, so if the length of our leg equals 8, and our hypotenuse is leg times root 2, then the hypotenuse is just going to be 8 times root 2, or 8 root 2. Cool. Very simple for that one. Okay, let's try out B. Over for B, what do we notice? I notice that our hypotenuse is given to us, but not our side lengths. So we're going to find out what these side lengths are. And remember, in a 45, 45, 90, the side lengths are always going to be the same over here. So that's why they put x and x. Cool. So we can automatically tell that this is a 45, 45, 90 because these side lengths are the same, x and x. So we can assume that this triangle is an isosceles triangle, or 45, 45, 90 as well. So let's find out. So remember, our leg is going to be x. So our hypotenuse is going to be your leg times root 2. Okay, so let's figure this out. If our hypotenuse is 5 root 2, you might already have an idea what the side lengths will be, but let's prove it, okay? Our hypotenuse is 5 root 2, and that's going to equal our leg. We don't know what the leg is, so I'm just going to say x times root 2. Okay, well, if I wanted to isolate this variable x, what are we going to do to both sides of the equation? We're going to divide both sides by root 2. Okay, so 5 root 2 over root 2 is just going to be 5. And then x times root 2 over root 2 will just give us x. So what is the missing side length here? It is just going to be 5. And it kind of makes sense because look, our hypotenuse is 5 root 2. So if our leg is 5, our hypotenuse is just 5 times root 2, or 5 root 2. And that's how you can use the special right triangle to find out missing side lengths. Okay, that's it. Bye.